Hello everyone. In this video we are going to explore the Apollonius theorem and some very beautiful and interesting result from the variation of the triangle. And at first, the Apollonius theorem states that the length of the medium of a triangle will be related to the length of its sides by this expression. And we have the a square minus 2b square, which is the middle length here, plus c square, the side length, is equal to 2m square. And we will first prove this relation in the next section. So to prove the theorem, we first draw a height from the vertex of the triangle to the base, and we label it h. So now we can divide the right portion of the m into two parts, into x and m minus x. And now we are going to consider three right angle triangle. The first one is this one, the AH and m plus x. And we can write the Pythagoras theorem, m plus x the whole square, m plus x whole square plus h square is equal to a square. So this is the first triangle. And then the next right angle triangle is CH and m minus x. So we can write it as m minus x whole square plus h square equals to c square. And the final right angle triangle is here, the BH and X. And we can write it here, X plus H square equals to B square. So now we can simplify these three expressions. I'm going to adding the first two equations left by left and right by right. And we are going to multiply the terms out, which is m square plus 2mx plus x square plus h square, which is the left hand side. And then the second equation with m square minus 2mx plus x square plus h square. And this is the left hand side. And for the right hand side, we add up a square plus c square. So we can cancel some terms. 2mx we can cancel out, and we can group the terms. We see there are two m square terms, so we can group it like m square plus there are two x square terms, and there are two h square terms. We can group it like this on the left hand side, and equals to a square plus c square. But we have another relation here, which is x square plus h square. So we can replace the last two terms by b square. So we have 2 multiply bracket m square plus b square equals to a square plus c square. And now we can expand the 2 into the left hand side. And then we arrange the term, the 2b square on the right hand side. And we have 2m square equals a square minus 2b square plus c square. And we finish our proof. So now let's trisect the base like the figure below. If we trisect the base, then for each portion we label it as m. And then we will have 4 line segment, the A, B, C, D, which is labeled here. So now we can apply the Apollonius theorem we proved before. We first consider the left two triangle, which is this part. And we can just put it down, the previous result, a square minus 2b square plus c square equals 2m square. And then we can consider the two right triangle. the two triangles. And then we can express the similar relationship like b squared minus 2c squared plus d squared equals 2m squared, like this. So now we have two equation. I label it the first one as 1 and the second one is as 2. And now we subtract 2 from 1. So we are now doing the 1 minus 2. On the left hand side, okay, so let's do it slowly. We write the first term here, minus bracket b squared minus 2c squared plus d squared equals, and for the right hand side, the two m squared cancel each other and become 0. So if we expand the terms here, we will have a squared minus 3b squared plus 3c squared minus d squared equal 0. So now we go one step further and we are going to divide the base into 4 parts. And then we can write similar relationship using the Apollonius theorem by considering the first 2 triangle, the second 2 triangle, and the last 2 triangle, and we write the relationship as below. So we are going to manipulate these 3 equations as below. We are going to add up the first and the third equation minus 2 times the second one. So let's see what happens. And we have a squared minus 2b squared plus c squared, which is the first equation, plus the last equation, c squared minus 2d squared plus e squared minus 2 times the left hand side, b squared minus 2c squared plus d squared, like this. And then for the right hand side, we have 2m squared, which comes from the first equation, and then plus another 2m squared, which comes from the third one, minus 2 times the 2m squared, which comes from the second equation, and of course is equal to 0. So let's see what happens on the left hand side. We have a squared, which is still here, and we have minus 2b squared here, and then we minus 2b squared again, so we are minus 4b squared. And for the c squared, we have c squared here plus c squared, and then we have negative 2 times negative 2c squared, which is plus 6c squared. And for the d terms, we have negative 2d squared, and then we have the negative 2 multiplied d squared, which is negative 4d squared. And then finally, we have the e squared term alone, and we have plus e squared in the last term. So now let's do it one more time. We divide the base into 5 parts. Oh my god, but it's okay. So now we have 4 equations coming from the Apollonius theorem, and then we are going to manipulate them as the first equation minus 3 times the second equation plus 3 times the third equation and minus the last 4th equation. So let's see what happens. Oh, and I may use some the speed up video here. Oops. Minus the last. And then which is equal to, of course, the right hand side is 0. So let's see what happens. And for the a square, it is still here, a square. And then for the b square term, we have negative 2b squared, negative 3b squared. So we have negative 5b squared in total. And then for the c terms, we have c squared, and then we have minus 3 times negative 2c squared, and then we have plus 3c squared. So in total we have plus 10c squared. And then for the d terms, we have negative times d squared, and then we have 3 times negative 2d squared, and then we have one more negative d squared. So in total we have negative 10d squared here. And then for the e squared term, we have 3 times e squared, and then another negative times negative 2e squared. So we have plus 5e squared. And then for the f squared term, we have negative f squared here. So now let's gather all the results together, and I list them all below. And we can see that some interesting pattern comes out. The binomial coefficient in the first line, the 1, negative 2, and 1. The second line is 1, negative 3, positive 3, and negative 1, and so on. And this is exactly the same as the Pascal triangle, but with alternating side. So if we continue the process, if we divide the base into n parts, like the picture above, we can write a general expression for the relationship between the side. So we can do it like the summation from r equals 0 to r equals n, and we have the negative 1 to the power of r, and then we have the binomial coefficient ncr, and times the x sub r, we take whole square, and this expression is equal to 0. And this is what we can observe in the Apollonius theorem if we divide the triangle into n parts in the space. So I hope you guys enjoy this video, and please like and subscribe to my channel, and we'll see you in the next video. Thank you. Bye bye.